Okay, let's make sure number 2 satisfies. Is it continuous on a closed interval A to B? You can draw your pencil the whole time, never lift your pencil. Is it differentiable everywhere? From the open interval A to B. Yeah. So we can draw a secant from those endpoints. In this case it cuts through, but that's just fine. And because it's continuous on the closed interval A to B and differentiable on the open interval A to B, we should be able to find a tangent line somewhere that it's parallel. So with my marker, tell me when, I'm just going to follow the curve along, marking the slopes. Tell me when I should stop when I'm finding a tangent line that's parallel. Definitely not parallel. Let's try that again. Yeah, about right here, right? Is that the only place? No, if I keep going, I have another one about right there. Yeah, good. So there can be more than one. Okay, number 3. Is it continuous on the closed interval A to B? Yes, it is. I can take my pencil. Is it differentiable on the open interval A to B? No, why not? Cusp. So it's not differentiable. So therefore, we are not going to be able to find a tangent line that has a parallel slope. Okay, number 4. Is it continuous from A to B? On the closed interval A to B? No, because of this tangent line. Or not tangent line, asymptote, yeah. Not continuous. Okay, number 5. Is it continuous on the closed interval A to B? Yep, I can go from A to B and follow my pencil along. Is it differentiable on the open interval A to B? Even though this is a cusp here, I said open interval, right? So is it including right there? No, so it is differentiable everywhere. So we can draw a secant from A to B, and we should be able to find at least one place where the tangent line has a parallel slope to that secant line. So tell me when yeah, more like right there, right? So the only place. No, we have one right here as well, right? Those are all looking pretty parallel. Okay. And what about number 6? Is it continuous on the closed interval A to B? On the open interval, but the definition is it on a closed interval? Because is there actually even a point at A? No. So this is not a closed interval. And number 7, is it continuous on the closed interval A to B? No, because of the hole, right? So this one's not continuous. So what we found on a bunch of these, the ones that worked, we found a point C where we could find a tangent line. Right here, there is an x equals C where the tangent line has a slope that's parallel to the secant line. So this would be f of C. And here we have found 2 C values, 2 points along the curve, C1 and C2, where the slope of that tangent line is parallel to the secant line of A to B. And let's see which other ones. How many C values did we find here? 2. C1, C2. I think those were the only ones, right? Okay, flip it over. Mean value theorem. Couple things that it has to satisfy. It must be continuous on the closed interval A to B. Maybe you should remind yourself that's closed. Because differentiable is not a closed interval. It's differentiable on an, what type of interval is this one? Open interval. A to B. So we saw that one example, number 5. If we were looking at the full function, it wasn't differentiable at A. But we didn't care about that because we're looking at an open interval, A to B. If both of those are satisfied, then there has to be a number C, or some x value, along the curve, such in the open interval A to B, such that f prime of C, so the tangent slope, f prime of C is the tangent slope, is equal to the secant slope. The tangent slope, remember that word instantaneous, rate of change, I think you only have one box. So draw this box in on the left. And the box on the right, put in secant slope, is the average rate of change. If f is continuous on the closed interval, A to B, and differentiable on the open interval, A to B, then there must be at least one. We've seen pictures where there's more than one. There must be at least one number C in that open interval such so that the tangent slope, or the instantaneous rate of change, is equal to the secant slope, or the average rate of change. The instantaneous rate of change is equal to the average rate of change. The tangent line slope is equal to the secant line slope. Does that make sense? And there's another picture. So, we're going to find the value of C without looking at the graph using functions. F of x equals a quadratic, x squared minus x minus 6. So we need to find f prime of C. What does that mean? Tangent line. So how do we find tangent lines? Take a derivative. F prime of first x. We don't know C yet. F prime of x. What's the derivative of that, Alex? Good. 2x minus 1. And are we on a closed interval? Let's actually make sure our two things check. Are we on a closed interval? Yes. Is a quadratic continuous? It is continuous. And differentiable everywhere. There are no cusps. It's not like the absolute value where we have a sharp corner. So it's continuous and it's differentiable. So we're allowed to continue. Okay? So f prime of C would be, if I just plug in C, I would get 2C minus 1. Do you agree with that? F prime of x is 2x minus 1, so f prime of C is 2C minus 1. Okay? So we have 2C minus 1 has to be equal to f of b minus f of a, the rate of change, average rate of change. F of, what's b? Yeah, this is a, this is b. F of 3 minus f of, what's a? 0 divided by 3 minus 0. This is just rise over run. Okay, so let's find f of 3. F of 3 just means I take my original derivative and I put a 3 in. I put it in brackets. 3 squared minus 3 minus 6. That's f of 3. We're going to subtract, I'm going to put it in brackets, f of 0. F of 0 just means I do 0 squared minus 0 minus 6. All over 3 minus 0 is just 3. Any questions? I'm not plugging that in. So if we do a little math here, we have 3 squared is what? 9 minus 3. Minus 3 minus 6. What is 9 minus 3 minus 6? Okay, so we get 0 minus a negative 6, which will be 0 plus 6 over 3. So 6 over 3 is just 2. So we have 2c minus 1 equals 2. Hopefully you're right, a little smaller than I am. So what is c? Oh, bummer. Yeah, 3 over 2. Okay, so we'll continue with mean value theorem next time. U3. When are you coming in to take the test? What? When are you coming in to take